A6. The metric system. The metric system is used throughout the world, with the exception of the United States. If you look here, this is a map that's showing usage of the metric system. This dark blue, basically showing the entire world, and this United States, this lighter blue, is an exception. And Canada here, it's actually mixed. So there is some usage there, but the United States stands out as not using it. And let's see, history for that. Well, if you look back in England, 1760, England started industrialization, and the United States followed in the by the 1800s. Throughout the 1800s, and tools and dies are then entrenched in the British system. The United States has a customary units in the early 1830s, which is derived from the British system. So one might argue that, it's too hard to change when you're already entrenched in the industry. But now, centuries later, you would think, come on, you need to get with the program and change. Now, the scientists in the US, when we publish, we will use the metric system. So that's for years now, we've been using the metric system in publications. But in industry, like if you're driving down the road, for example, you're going to see miles, like instead of kilometers. So that makes it harder for folks in the US to study physics, because since the metric system, which dates back to the 1790s, is the system that's being used, and those in the US are, growing up with the British system, then they kind of have to have a units problem when they study physics that everyone else in the world wouldn't have, because they're used to the metric system. They would know what a gram is, for example, centimeters and things. But centimeters are used in the US. The rulers do have the centimeters, so let's go ahead and list some of the ones, the common ones. You have the metric prefix, and then we'll have an abbreviation for the prefix, abbreviation, and then we'll have a value for the prefix, and then some sample usage. So here, centa would be a prefix, abbreviation is little c, and the value is 1 over 100. It's 100th. And sample usage would be centimeter. You can put it with anything. That's the nice thing about that. Centisecond, centimeter. And then this little c and this little m, you could write that as a little c, little m. The left is the prefix and the right is the actual physical quantity unit, the meter. Well, actually the centimeter is the unit, the whole thing. But you can think of it as a prefix in front of the basic one, the meter. So here, if we look at another example, milli, then that's little m, and that's 1 over 1,000, and that would be millimeter as an example. And those two m's there, you would say little m, millimeter. Another metric prefix is the kilo, and that's a little k, lowercase k. If I ever write an uppercase K, I'll do something maybe like that to emphasize it. This is 1,000. And an example would be a kilometer or a kilometer, but we say kilometer. And that's little k, little m. So there's 3 of them. Now we're going to be talking about computer applications in units that we're going to be looking at in this chapter. So I want to point out that kilo, while it means 1,000 in the metric system, in computer science, kilo is 1,024. Now the reason for that is it's a power of 2. In other words, 2 to the nth power. Let's look at these. So if the n is equal to 1, let's have the n here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is going to be 2 to the nth. 2 to the 0th power is 1. In other words, you're taking 2 as a factor 0 times, so it's just a 1. If you take 2 as a factor 1 time, you get 2. And then if you want 2 squared, it's 2 times 2. And then if you want 2 cubed, just multiply the 1 to the left by 2 again. 8, 16, 32, 64. So that's 64 is 2 to the 6th power. That is, if you multiply 2 where you have 6 factors, you're basically taking 2 times 2 times 2, which is 8, 2 times 2 times 2, which is 8, and 8 times 8 is 64. Then you have a 128. If you double that, 256, 512, and 1024. So the closest thing to 1,000 in terms of the power of 2 is 1024, and 2 is very sacred in computer logic, where you have 2 values, a 0 or a 1. It's a binary system. So that's something we should remember. Now, metric prefixes that are larger, if we continue our little table here and look at kilo, and then mega, and then giga, and then tera, these are familiar to folks because of hard drives. But when I went to school, we had to learn like the giga and the tera. We didn't know about these hard drives. So here, this would be little k. Now, since little m was already used for a milli, this is going to be big M. And then giga is going to be a big G. And then tera is going to be a big T. So here, the description here, or the value, okay, the value or the description, this would be 1,000. This would be 1,000,000. This would be here 1,000,000,000. So you can look at these as this is 10 to the 3rd. In other words, a 1 followed by 3 zeros. 10 times 10 times 10. 10 is a factor 3 times. That's equal to 10 cubed. And that's equal to 1,000. So 1,000,000 would be a 1 followed by 6 zeros. So it's 10 to the 6th power. 1,000,000,000 is 1 followed by 9 zeros, 10 to the 9th. And then the trillion would be a 1 followed by 12 zeros. And we're familiar with these for hard drives, from hard drives, megabytes, gigabytes, and terabytes. When I was a kid, my best friend, his brother was older, and I would learn things from him, and he told me the idea of the googol. I'll just go ahead and do this. This is not part of the metric system. I just want to do this for fun. So the googol, spelt this way, is equal to a 1 followed by 100 zeros. It's a big number, all right? And then the googol plex is 10 to the googol power, which you could write as 10 to the 1. Like, this is a little weird. So you would say 10 to the googol power. I had trouble understanding this. I remember being frustrated until I figured out that if you looked at 1,000, 10 to the 3rd, by analogy, we did an analogy, then this thing is like saying I want 10 to the 1,000 power. In other words, I need to write 1,000 zeros after here. So in other words, 10 to the 3. In other words, 10 to the 1,000. 10 to the 1,000. So that helped me understand that you have, this is an incredibly big number, this is googol, but if you have 1 followed by a googol number of zeros, that is incredibly large. So if you spell here, say, googol like this, Then you get the Google search engine, and if you do the same thing here, you get the Googleplex, the headquarters in Mountain View, California. There's Google, spelled a little differently but inspired by the concept of Google. 10 to the 100th power. That's kind of neat. Well, here are all these prefixes, the metric system, and I like these dates here. Some of the early ones going back to 1795, like the kilo and here and some of the others. You don't need to memorize all these. We'll be introducing them in the course, as we need them. But this is the metric system from here Wikipedia, showing all the prefixes and their values and the dates which they were introduced. And here's some neat little graphics. Here's the penny, and the penny has a mass of 2.5 grams. And that can help us understand, and those that were brought up with the British system. In the U.S., for example, can hold a penny in their hand, and that's 2.5 grams. I like these old scales. Isn't that cool? Let's look at that. Old scale. So in the U.S., they use ounces and pounds and things, and really should be using grams. Isn't that nice here? Look at that. The scale. Okay. That ends our section on the metric system.